Hello everyone, welcome to new class. Today's class is about nodal equations by
mesh analysis,
inspection method.
we are doing in matrix form, that is this is
I into R is
mesh
equal to V
analysis
form.
by inspection method, and in nodal analysis by inspection method, Y matrix into V matrix is equal to I matrix, that is
Y is admittance,
then V is voltage matrix, then I is the current matrix, that is in 2 by 2 matrix form we can write y1, y12, y21, y22 into v1, v2 equal to i1, i2. So this is the matrix form for the nodal
analysis by inspection method.
and there are some procedures for writing this matrix. So the first procedure is convert the practical voltage source into equivalent current source before putting in the matrix form. So convert voltage source into current source. Then this method can be applied for both AC and DC. Next is, if there are n nodes, then the number of equations required, that is the number of unknown node voltage, is equal to n minus 1. Then fourth one is 1 1 element, that is y11 or y22 element, means it is the sum of reciprocals of the resistances connected to node 1, and 2 element means sum of the reciprocals of resistances connected to node 2. So reciprocal of resistance means it is the conductance, and 1 element and 2 element here are called self conductance. So the reciprocal of resistance is called the conductance, and the 1 element and 2 element are called self conductances. Then next is 1 2 and 2 1 elements, that is y12 and y21 elements are equal to the negative of the sum of reciprocals of the resistances joining nodes 1 and 2. That is, reciprocal of resistance means it is the conductance. So 1 2 and 2 1 elements are the negative of conductances joining nodes 1 and 2. Then the last one is, and here 1 2 and 2 1 elements are called mutual conductance. So here this is called mutual conductance and this is self conductance. Then sixth one is the current matrix, that is the I matrix is called driving currents, and these driving currents are positive if they flow towards the principal node. Principal node means other than the reference node. That is, the main nodes are called principal nodes. So current matrix, driving currents, the driving currents are positive if they flow towards the principal nodes, negative if they flow away from the principal node. For example, consider this circuit. Then here we can write the matrix form. That is, first one is y11. Y11 is, so first of all mark the nodes 1, then 2. So these two are the principal nodes and this is the reference node 3. Then here we can write the matrix, that is Y11. Y11 is the sum of conductances connected to node 1. That is here R1, R2 and R3 are connected. That is 1 by R1 plus 1 by R2 plus 1 by R3. So these are the conductances. So conductance means reciprocal of the resistance. Then next is R22, Y22. Y22 means the sum of conductances connected to node 2. That is 1 by R3 plus 1 by R4 plus 1 by R5. Then next is Y12 and Y21. So here Y12 means connected to the node 1 and node 2. There is only one resistance, that is R3, and its reciprocal. Also put negative sign, that is minus 1 by R3. Here also minus 1 divided by R3. Then into V1 and V2 are the voltages. Then here current matrix is I1, I2, and here we have to convert this voltage source into current source. So I1 is equal to V1 divided by R1 and I2 is equal to V2 divided by R5. So here we get it V1 divided by R1 and V2 divided by R5. And here we have to put sign. So here this is minus 2 plus. So the current direction is in this way. And here also minus 2 plus. So current is in this way. That is, this current is flowing towards this node. So it is positive. And here this current is flowing towards this node. So it is also positive. Then we can simplify using the Cramer's rule. So this is the method for writing the nodal equations by inspection method. Let us do a problem. Using nodal analysis, find the current and voltage in 5 ohm resistor. So this is the given network. So first of all we have to mark the nodes. So this is node 1, then node 2, node 3. So these three are the principal nodes and this is node 4, that is the reference node. And here 4 minus 1, that is there will be 3 unknown voltages. So V1, V2, V3 are the 3 unknown voltages. So to find the current and voltage in 5 ohm resistor, we have to find V1 and V2. So first of all, we can write the matrix form. That so in matrix form, Y into V is equal to I. Y means, so the first element is the self conductance at node 1. That is here 5 ohm and 4 ohm are connected. That is 1 by 4 plus 1 by 5. Then second element is Y12. Y12 is 1 by 5, that is negative. Then Y13, 1 to 3, that is minus 1 by 4. Next is Y21. Y21 is minus 1 by 5. Y22, that is the conductance is connected to node 2, that is 1 by 5 plus 1 by 1. Then Y23. Y23 is, there is no conductance, so it is 0. Then next is Y31. Y31 is 3 to 1, that is minus 1 by 4. Y32 is 0. Y33, that is the conductance is connected to node 3, that is 1 by 4 plus 1 by 2. So this is the Y matrix. Then unknown voltages are V1, V2 and V3, that is equal to then the driving currents. While considering the node 1, this 1 ampere current is flowing away from the node, so it is minus 1. Then node 2, this 2 ampere current is flowing towards the node, so it is plus 2. Then to the node 3, this 2 ampere current is flowing away from the node, so it is minus 2. So this is the matrix form. So after rearranging, we can write in this way, that is, this is 0.45 minus 0.2, then minus 0.25, minus 0.2, 1.20, minus 0.25, 0, then 0.75. Then to find V1 and V2, we can use Cramer's rule. So by Cramer's rule, we can write V1 is equal to delta 1 divided by delta, and V2 is equal to delta 2 divided by delta. And delta is the determinant of this Y matrix, and delta 1 is changing the first column elements with the current matrix, and delta 2 is changing the second column elements with the current matrix and find the determinant. So here delta 1 is changing the first column elements with the current matrix, and delta 2 is changing the second column elements with the current matrix. So first of all find delta. So delta is determinant of the Y matrix, that is 0.45 into 1.2 into 0.75, then plus 0.2 into minus 0.2 into 0.75, then minus 0.25 into 0 minus plus 0.25 into 1.2. So after computing, we will get a 0.3. Similarly, delta 1 is equal to determinant of this one, that is minus 1 into 1.2 into 0.75 minus 0, then plus 0.2 into 2 into 0.75 minus 0, then minus 0.25 into 0 plus 2 into 1.2, 2 into 1.2, and after computing we will get a minus 1.2. Then delta 2 is determinant of this one, that is 0.45 into 2 into 0.75 minus 0, then plus 1 into minus 0.2 into 0.75 minus 0, then minus 0.25 into 2 into 0.2, then plus 2 into 0.25. So after computing, delta 2 is equal to 0.3. Now we can find the values of V1 and V2. So V1 is equal to delta 1 divided by delta, that is V1 is equal to delta 1 is minus 1.2 divided by 0.3, and that is equal to minus 4 volt, and V2 is equal to delta 2, that is 0.3 divided by 0.3, that is 1 volt. So the voltages we have found. Now we have to find the current. So current through the 5 ohm resistor is V1 minus V2 divided by the resistor 5, that is V1 is minus 4 minus 1 divided by 5, that is minus 1 ampere. So this is the current through the 5 ohm resistor, and these are the voltages at nodes 1 and 2. And through the 5 ohm resistor, the voltage is V1 minus V2, that is minus V1 minus V2, that is minus 5 volt. So in this way we are doing the nodal analysis. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.